Hello everyone and welcome to this lecture. In this lecture, we're going to discuss how can we detect corners and edges as features and extract them out of a given image. All right, so edges are mainly identified when change in intensity is noticed in one direction. For example, if you guys can see here, this is an image of a truck. So what we could do is that if we pass, let's say, a kernel, and we move or we scan that kernel to the right, as you guys can see here, you'll find that there will be an edge detected here because there is a change in intensity between the pixels before that edge and after that edge as well. Okay, so that means that the edge has been detected. Moving forward, you will find that, again, if you scan that kind of kernel or that matrix on the original image, you will find that we are able to detect another edge here. So that would give us kind of, like the boundaries of our object. And that's how we can detect edges within our image. However, corners are a little bit different. Corners are mainly identified when shifting a window in any direction over that point gives a large change in intensity in all directions. So let's take a look. So again, if we use the exact same kernel, if we pass it by here, you will find that there is a corner that has been detected because there has been a change in the intensity in both directions, in X and Y, or maybe in additional directions as well. And that's how we're able to detect corners and edges. So let's take a look at how can we extract or detect corners and edges within our image. So again, corners are regions in the image with large variation in intensity in all the directions. So what we're going to do is that we're going to use kind of an OpenCV, kind of ready-made for us kind of function that can obtain what we call it Harris corner detection. All right, okay. I'm not going to go into a little bit of the like in details of the mathematics of Harris corner detection, but the overall idea is that Harris corner detection try to find the difference in intensity for kind of a displacement of U and V, which is simply if you move in the X and Y directions, and you find there is a change in pixel intensity in both directions or in all directions, then that means there is a corner that has been detected. So how can we perform that in OpenCV? I'm going to say, okay, cv2.corner Harris, pass along our image, pass along our block size, which is simply the size of the neighborhood considered for corner detection. Like what neighbors are you going to look at? Think of it as kind of, like the size of the dimension of the window. And then we're going to specify the K size, which is the aperture parameter of Sobel derivative used. If you guys recall, this technique kind of relies on Sobel derivative. And if you guys remember, when we obtained the Sobel derivative, we had the K parameter that kind of, we can tune to change kind of the power or the intensity of the derivative, and that's where we can specify it here, and that's K size. And then the last parameter is K, which is the Harris detected free parameter in the equation. So basically the Harris corner detection just use kind of an equation, and this equation there is a K parameter, and that K parameter is called Harris detector. Again, I'm not going to go into kind of the equations and the implementation of Harris corner detection, but if you set it to 0.1, that would be kind of the default value that can be used, and we'll be able to kind of successfully detect most of the corners in our images. So as you guys can see, this is our given image, and afterwards, when you apply the Harris corner detection, you will find that here it shows you kind of, like where the corners have been detected. So all the image here is kind of plain gray. However, the white pixels in here shows you where the corners that have been detected within the image. And what we do is that we take our image, we take our Harris corners detected here, all the white pixels, and maybe shift them to green, okay, and plot them on the image, as you guys can see here. So as you guys can see, the technique have been able to detect corners here, 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 and so on, which is, unfortunately, it's a little bit noisy. As you guys can see here, it's a little bit noisy, but the overall idea that has been able to detect the important corners within our truck and within our object, basically. All right. The last step, which is what are the corner detection limitations? So detecting corners as features in images can work well even if the image is, let's say, rotated, translated, or experience any change in brightness. So even if the image has, let's say, like a little bit darker, a little bit like lighter, brighter, or even if the image is rotated, translated, as well, we would be able to use Harris corner detection to actually still find the exact same corners. However, this technique is a little bit challenged if the image is enlarged or if there is some of the scaling, for example, issues. For example, if we have a corner in an image in this like size, okay, so if we zoom in the image, if we try to, let's say, zoom in or do, let's say, image pyramiding, you will find that that corner in a small image would result in a multiple corners in a zoomed in large image. So if we zoomed in, you'll find that we can find a corner here, corner there. So the technique might be challenged in a way when we go from, or we try to scale the image or zoom in specific image. And that's why we don't rely directly on just corner detection. We actually use kind of a mix of features using the colors, hog features, use or histogram of oriented gradients, using Harris corner detection as well, and using canny edge detection to kind of mix them together and come up with features that we could use to train a classifier that can be used for object detection. All right, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it, and see you guys in future lectures.